So folks, as today we did say the next radio will be an Amstrad 901, and it is, and it's an early version with the power connector you can't get. Customers got the power lead, otherwise the only alternative is to fit the square round type, and in this case it's a wider connector, so you end up having to, we've got an adapter plate which somebody makes for us. It's pretty weak, but we support the thing with hot glue on the inside. So we've got, because the viewer sent us the correct power connector. I wish one of these people would do it'd be nice if somebody did a 3D one. Luckily most of them are the square rounds, but there's three types kicking about. I mean, those fake sets have a different connector as well sometimes. I mean, it looks quite a weak design now, which is probably why it was soon obsolete. These have been obsolete. These were obsolete when these were still in production. It's like grandstand base stations. The NEC synthesizer chip, the UPD2812C, used in those was obsolete when they were manufactured. They must have had a bucket load of them. They wanted something to put them in. And the same applies with the Binatone Long Ranger 612 and 40. They all use the same well obsolete synthesizer chip, but they work well. They're very reliable. I've never had to change one, but I have had to change a UPD2812C twice in two different grandstand bases. In fact, nearly every part in those is NEC. When I was at Nottingham Radio, we had a young lady come round trying to persuade us to do car phones, and they called the firm was called National Executive Car Phones. I'm going back to late 90s, late 80s, when there weren't hand portable mobile phones. There were things you fitted in a car with a boot pack and that. And she says, you see that they're our own make, these at NEC. What National Executive Car Phones? I said, no, NEC is Nippon Electric Company. And she didn't know that. I said, no, I'm not dealing with somebody with a fake name like that. What a load of sales twaddle. Oh, there are. Fancy making up a name for your firm which matches a well-known brand. You know, imagine you say, well, these are our own makes, Sony. It stands for, I don't know, Southern something, you know. Oh, dear. All right, we'll take them. Oh, so in his letter, thank you for agreeing to retune and test and the work that needs done. My Amstrad 901 from Japan. It means a lot to me as my original one was stolen and I had to get this one off eBay as a replacement. So this does happen, and this is going to, you know, I don't know that his original one was a made in Japan one, do I? He has also come with the Action Man mark, and once again I have to say, remember, these were withdrawn and you were given a free replacement. These were all destroyed. So when a set presents with one of these, remember it will never work properly. They were withdrawn and replaced under warranty. So it's a great thing to have, but you can't use the set with it. Otherwise you're going to have to be putting wedges of paper inside and squeezing the trigger just so. Yeah, it's a wonderful thing to have this original mic, but it isn't to use. It's a Shelf Queen mic. I'm going to open it up because I want to make sure there's nothing going to go bang inside, with it being a set so meaningful to the customer. Oh, you know, it's had some dry joints, hasn't it? Which you don't suffer from. I'm going to clean the board with isopropyl alcohol. It's not going to do. It's not going to do 4 watts with the 2 watt resistors in it. I'll send him them back for posterity, but it ain't going to work. Right, so we'll get it connected to power. It smells of clean soap household. And I was saying that with the grandstand bases, nearly every component in there is NEC, but nearly every component in these is Sanyo. So I'm not going to use his mic. I'll go and find our standard replacement mic. Unless it's kicking around. It's kicking around on the bench because nobody's tied it up. Can't get the start, can you? It's first thing in the morning. It's not even 9 o'clock yet, but I wanted to make a start on this because I want it done today. I've got a funeral at 12 noon, which means I need to be at church for 11, and I've got an organ tuning this afternoon booked for 3 o'clock, and we need to be setting off for 2 for that. So, you know, that's the day taken up with various church things. So I've only got, you know, like 3 hours this morning. Hopefully this can be done within an hour. 25th April 25, Amstrad 901. I'm pining for a fake one, you know. They're alright, they're less reliable parts, but it's only the squelch lets them down. Right, so we're connected up, 13.8 volts, power supply on. There we go. Let's try it on public address first. You can never see what these are. You have to get the light on an exact angle. PA. PA. Testing 1 2, testing 1 2, testing 1 2, Wallow. Right, so that's that. So we'll turn the RF gain to full, squelch to minimum, tone to halfway. No noisy controls either. I'm sure this looks quite low hours. I just don't know why there's some dodgy soldering. Right. We'll switch picture in picture on, and then we can all see. Let's put that there. So I'm on my 3 watt scale. We're on channel 20, and it's doing 2.9 watts. It's a bit like a news set, isn't it? How many times have I said that? Except this one we'll be able to do something about. So, usual thing, if we can't get 3.5 watts out of it, then we change the ballast resistor. More modern name for the ballast resistor would be to say a dropper resistor. The more old-fashioned name than a ballast resistor would be to say the Beretta, because they were in a case that looked like a priest's hat in the 1930s. Right, change channel. .8 watts on channel 40, 2.8 watts on channel 1. It's well balanced. Back to channel 20 and 1.2 amps transmit. Low power. It's non-adjustable on these sets, and at the moment it's 220 milliwatts. That could go up and down or down as we do the retune. Deviation for what it's worth on this test set. We'll go to the other test set in case this is lying. Just have to tune it in. Wallow. 1.8. We will have to do the VCO. I'm going to check the frequency. Test gear's only been on 10 minutes, so it won't yet be accurate, and it'll be lower than it will end up being. If I can find the camera remote, we'll go over to camera 2 and see what the frequency counter has to say. 79085. So it's probably about 10 more than that. But I'll put that down. 2779085. So if we left it about 4 hours, it'd probably be 79095. I'll set that right at the end. But actually, I'll set it. You know what? I'll set it here and now, and we'll trim that off video at the end. Now these are 40 odd years old, they rarely will go fully up to the correct frequency of 79125. As long as they're over 100, I'm happy. Otherwise we've got to start changing the crystal, and trying to find a crystal that works is another thing. So let's see how far we can go. It's nothing to do with use or anything, it's just look at the drawers to how the crystal's aged. So that's as far as we're going to get it. But I won't write that down at this point because it will rise probably about 10. So what we've got, 111. So I'll put that in the signal generator, and that's what we'll do with all the receive tests and tune up on. So close, you wouldn't have even noticed it was at all off frequency at 79085. By the time they get to about 79075, you just could start to notice they're dropping off frequency. And I think it's got to be something like 79025 to be legally off frequency. So make sure we get the right in, so that we're doing everything fairly. We'll be there. That's pretty sure. It doesn't sound very happy. I'll go over to the test equipment speaker. There's an earth because it's an isolated chassis. Just plonk the earth there. Are we in the right hole? Yeah. I think we'll connect it to the power earth. There we go. It sounds a bit strangled, like the detector's out. Maybe totally wrong. These are usually capable of better than 0.4. It is currently 0.44. We often see these down to 0.2 something. So we've got 0.37 on 10. And if it does 20, I doubt it's going to. No, it won't achieve 20. That's because something's out. Squelch. Put that. Tell you what, put the squelch to full. And I like it to be 100 microvolts. 1, 3, 10, 30, 100 when it opens, but it doesn't. It never opens. At full. Let's see where the threshold is. Turn it down on the radio to threshold with the signal generator on standby. I've parked the signal generator at 0.3 of a microvolt, switch it back on, straight in at 0.3. S meter, in the UK CB radios it's 100 microvolts for S9, and it's being a bit generous at 40 microvolts. On the transmit meter, it's a relative power meter, so it isn't pre-programmed like most modern ones. So if we're going to transmit, it would light 4 lights if it was doing 4 watts. Are we still in low power? It's lighting all of them, so that's not right. Doesn't have a meter lamp. Switches work, potentiometers work, sockets work. So we will start by doing the VCO, and I better get the manual out because I only did one last week, but I can't remember. Luckily it's still on the pile of tat, so I have to be doing things every day to remember. So channel 1 on these sets, and it's 2 volts, so I do know the test point is the far side of that capacitor. I think so I can get the prod onto it. Right, 2.2. I'm not going to change that, that's within. So on transmit, let's go into transmit. Just get my test prod on there again. It's 1.54, that does need adjusting. So I'm going to have to put my earth onto a crocodile clip. I'm going to run out of hands. And then it's the red trimmer capacitor. So we've got 2 volts now on transmit. So let go, we're in the receive now. We've got 2.1 on receive. So I may as well just now trim the receive, which is the coil here. They are interactive slightly. So we've got 2.04 on receive, going to transmit, got 1.88, that's fine, we'll leave it at that. Now on channel 40, you've got your kind of checksum to do. You want it to be about 4 volts. That's receive, that's transmit. And because they don't say what kind of meter they're using, you can't replicate it. You know, back in the day, the industry standard test instruments an AVO 8, so you'll find most of the service manuals will say with reference to an AVO 8 or with reference to a high impedance voltmeter. They'd put VTVM for vacuum tube voltmeter, meaning high impedance, because there weren't digital ones. So you've got to realise that with a traditional meter, when you put your prods across, it takes current, so it affects the reading. Whereas these type of meters, they don't take any current, do they? It's absolutely tiny, very high impedance. So it affects the results of what you get, and that's why they tell you what meter they're using in the service manual, except this. Right, so we've done that. So the danger if you don't do the VCO is you're going to have channels dropping off at the extremes of the selection. So you may find that nothing under channel 3 works, you might find nothing over channel 37 works. That would be indicative of the VCO being out. Right, now we'll start on the transmitter. And I can see we're going to be changing that. I'm absolutely convinced we're not going to get 3.5 watts. So, here we go. So we're 2.9, we're on channel 20. So that was absolutely the centre of the peak. The next one, not quite, but it's still 2.9 watts. Exactly the same. That doesn't look like it's been messed with. That needs a bit more heat. I'd probably need a bit more heat if I'd not been moved for 40 years. That's already in its ideal position, and then when we set the power with, it's just taking it to 3 watts. Needs more heat. Just do 3 watts at its peak. So it's changed the ballast resistor. So switch the radio off, switch the power supply off. I don't know why there's so much resoldering on this board. You don't suffer from dry joints. That's the other end. So look at our bag of Amstrad resistors. That's it. If you come up across one where it's been linked out, make sure you put one in, because that set will look like it's doing about 7 watts, well, for about 10 minutes till the PA transistor dies. But in fact, it's doing most of that on aircraft band. I've done that demonstration a couple of times. You know, ooh, look, I can get loads of watts. And we actually found the radio was doing something like 2 watts on aircraft band and 1 watt on citizens band. Yeah, really clever tweak up that, isn't it? It's great if you want the civil aviation authorities dragging you away by your hair when you've caused an airplane crash. So the sister flex there, I've got some somewhere. It would be nice to put another one on. You know, this is 6 or 7 watt rated. These are 2 watt rated. It says so on it, 2 watts in series. So it's 2 watts, isn't it? So getting 3 watts out of the set's quite good going. Now, where did I put this sister flex tubing? I don't know. You never know, we might just have to use some heat shrink. There's a piece there of something totally different. So if we cut that to more or less the same length, it's a bit thinner, but it's okay. It's a heat-proof fiberglass type of sleeving. Well, there we go. We've improved it. During COVID, we had right difficulty getting these resistors. even though they're made in England, or sometimes made in England. What does that packet say? These are Vichy brand, which are often UK, made in Mexico. And then when I've done this, I'll just go over it with the isopropyl alcohol, not just where we've done that repair, but all over the place where it's just not being cleaned. Just a lot of either rework at factory level or later. I can't say I often see that on these. I'll tell you what though, I can see a potential dry joint. It's not a dry joint yet, but it's potential. And that's not brilliant either. Not that I'm moaning at 40 odd years old. Not like tellies, you burn a hole in the board. Right, I'm just going to check that these screws are tight, or we can end up with microphony. Rackle, rackle, rackle. Because these are earthing the board to the chassis. There we are. Hopefully we'll get more than 3.5 watts. And if we pick up the trim tool off the floor, right, put the power back on. Let's see what it's now transmitting at. Oh, 4.2 watts. Right, so I need to re-peak this one. Then just the power with that one. Remember, these are 4 industrial watts, they're not hobby watts. This is how a government inspector is going to test. I think you'll all appreciate that hobby meters are going to read a bit generous, aren't they? Oh look, I'm doing all these watts, when you're not. Speedometers in cars are about 10% lower than reality. Okay, so we're doing 4 watts on channel 20. So let's look at the other channels. Want them to be within 0.1 of that. We've got 3.99 on channel 40. We've got 4.01 on. I'll just see if I can balance that with this. It is possible that I can. Not with that one I can't, but perhaps I can just touch this one a fraction. Let's go back to channel 40. Now we'll go back to channel 20 and reset it all. That didn't work. So, channel 24 watts, channel 1, 4.05, channel 40, 3.95. Still within 0.1, isn't it? Okay, so current consumption now on channel 20 is 1.284. So it was 1.2 before, 1.28. So we've gone up 80 milliamps and got another watt out of it, which just goes to show that it needed tuning, which I'm not surprised after this kind of time. So on low power, we used to have 220 milliwatts, and we now have 320 milliwatts, which is running slightly nearer to 400 milliwatts it's supposed to be. So that's a pleasing result. Right, let's do the meter. So the preset for the meter is there. I want it to read 4. That is where it should be. Now when we go to low power, it normally will show 1. Sometimes they show 2. There we go. So the meter is reading 4 for 4 watts. Not 5 for 3 watts. It's, I've already forgotten what this was. It was something like 2 plus 2.5, wasn't it? And it's now 2 plus 2. Right, we're on channel 20. Let's have a look at the receiver. I need my earth back on that. We'll start with the detector. I'm going to put 100 microvolts on. Let's look at the oscilloscope. Doesn't look nice. Detector is that one. That tool's not wanting to fit. Detector's right. Sounds like the IF screwed up. This is right at the top of its travel, like it's been messed with. See whether we can get it better. Now I've just done those IF adjustments. Not really. Anyway, see where we are with the front end. Let's go to the cyanide. The fact we couldn't get a 20 dB cyanide reading, wouldn't go beyond 18, tells me that either the detector or the IF screwed up. And I've had to adjust the 3 IFs because they were screwed up, but the detector wasn't. But it's still not quite the shape I'd like the waveform to be. Let's drop that a bit, do the front end. That was spot on. That was spot on. Not quite spot on. So the detector wasn't wrong. That was spot on, but these 3 IF ones were. Well, I'll take a reading at this, and I mean, theoretically, we should be tuned. I've got 0.46. Just check we're still on frequency. 79114. What's the radio now doing? 79115. So it's on frequency. Okay. So I've now got 0.44, which is what we had before. .35, say 3. It's not. There's no change. Can we get 20? We can't get 20. There's something wrong. This could be on a false lock point. Just going to do the IFs again. Well, I'm not sure what's happening. I don't think I've come across one which won't do 20 dB before. And you start to think, have we got an IF filter that's not right? Or have we simply got some capacitors in the amplifier that's not right? I'm just tempted to go back to PA and just listen to it. Not a very scientific test. So 1, 2, 3, 4, 5, 5, 4, 3, 2, 1. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1. 1, 2, 3, 4, 5. It does seem there's some distortion there. I think I need to look at this, the amplifier, I think. We'll come back to it. Just before we proceed with the amplifier, take picture in picture, just do the deviation with the other test instrument. Wow. Testing 1 2, testing 1 2. Wallow. Wallow. It's 3.2, so that needs to come down a bit. Wow. That's deviation, isn't it? Get the right one. Wow. Here we go. So that's that bit done. We turn that test instrument off. I've got to go off to this funeral, see what time we've got this evening to conclude this, hopefully. The next day, we've changed all the capacitors in the amplifier part of the radio, because it was clear there was a bit of distortion on public address mode. I mean, I can't tell whether there was on CB, but there's bound to be, because of two reasons. One, we've got that distorted waveform on an S9 signal, but that can be other reasons, which I'll come to. But we're at such a distance, you can't really listen to other people, and they're invariably off frequencies or using illegal radios, as you realise. So that's no test. So that's why public address is very useful. It's a bit silly if I've got to send Mr. Chippie a mile away to do a sensible test just for a quality thing. So we're going to go over this with isopropyl alcohol, but as previous repair. I'm a bit concerned. I think a couple of these capacitors have been changed before, but they've gone and used second-hand ones. We're going to test those in a moment. Now, when I took out this 1000 microfarad one, I've only got the circuit diagram in front of me. I didn't bother printing out the service manual, looking for the service manual. So I thought, well, when I unsoldered it, it fell out of the board, so I don't know what polarity it was. And although they can be labelled on the board, it is a bit subject to the quality of the screen printing. So I thought, I'll get a scrap set out and we'll look at the polarity. So if we just turn that over, and it is on, so I'll be careful. Let's plug that in. So I'll just turn it over. You can see we've got all these Nicky Kong highest quality possible capacitors in the audio section, and if we switch to PA, we've no longer got that distortion. So I'll just do that. Testing 1 2 3 4 5 5 4 3 2 1 1 2 3 4 5. Yeah, that's lovely. So if I switch to picture in picture and we put the signal generator on, I think we're on business in Skegness later today, so I'll take one of the vintage camcorders. Switch to the oscilloscope, and as you can see, I haven't reset the detector yet. I will need to do that. So when I had finished doing the capacitors, there was still some distortion, and I've changed the ceramic filter there, and that's tidied up the rest of the distortion. So if we'd have gone for that first, we might have tidied up some of the distortion, but not all of the distortion, because it was a twofold problem. The capacitors, I don't know which one. We'll test those in a moment. But what I'm coming to is this. We have these scrap chassis that we've bought in. It's not us or scrap sets. It's we buy them like this, you know, like off eBay and whatever. As you can see, you know, that's a no-hoper. What's that being left in the rain? It looks like it was a Mustang once. But when we look at these capacitors, you see the heat sink's been borrowed out of that. 1 2 3 4 5 for a start. Where's the big one? Somebody's had it. So I look on the next set chassis. We've got the smaller capacitors. Where's the big one? It's gone. I then turn to this fantastic Mustang 3000 that somebody smashed up. You know, like smashing up a Rolls Royce, isn't it? And it's still got it. So that tells me, out of those chassis, somebody's robbed the 1000 microfarad capacitor out of them, which is going to be the biggest culprit possible of being knackered. What's with these people who aren't going to spend 40 pence on a new capacitor, and they nick it off at something, a chassis that's 40 years old? It's absolutely mind-bogglingly bonkers. We see, especially with Americans, sorry American viewers, but there's people parting out, in inverted commas, parting out things. And it'll be a camcorder board. But it's not going to work, is it? Because it needs 40 capacitors changing on it. And yet it's telephone number prices. Board for Sony camcorder, $120. But it isn't going to work. So, needs new capacitors. I'm going to test those now in front of you. Perhaps they all work. But I'll tell you what, the distortion has cleared up by changing them. What's that going to cost the customer? A £5? So the most boring, I'll turn the volume down so as not to annoy people more than listening to me is annoying. Right, 3.8 microfarads. Let's put the other glasses on so I can actually see what the value is supposed to be. 3.3. So that's probably alright. Lower values, they can fail. Let's look at the next one. $51. What's it supposed to be? $47. Next one's supposed to be $100. But I won't put any of these back that are starting to go high. That's indicative of failure. We don't know how many hours this set is, but I'm convinced that 2 of these capacitors have been replaced in the past for second-hand ones. 100, what's it supposed to be? 100. They're all going to be disposed of. This has got corrosion on it. It's 49, what's it supposed to be? 47. It's 220. $237. Started to get a bit high. High isn't good, folks. And finally, the 1000 microfarad one, which definitely been swapped. That started to go high. So the point is, I turn up that volume, put picture in picture I want it to be. I turn up that volume, no longer any distortion. I switch to PA, no longer any distortion. So all those might read pretty okay, but they're not, are they? Right, we'll just do this detector. We want an S9 signal on the test set, which I've got. And we want a bit more volume. That's still, as it was, correct. I'm just going to do these IFs, turn the signal down a bit. I'll use the oscilloscope. I'm looking at the oscilloscope and the cyanometer. I can't do double picture in picture, so I just want to turn the S meter up because I'm going to look at that as well. And I inadvertently turned it the wrong way yesterday, didn't I? Yes, Mr. Tango, you did. Because I thought it was deviation. So I'll just run through these. We'll look at all 3 meters. I think that's right, we'll come back to it. Let's drop the signal a bit. Different scale. Yep, that's where I think we are. I'll now set the S meter. It's got 100 microvolts on the signal generator. I want it to read S9. But I also want it so that when we turn the signal generator up, we actually get plus 30, which we do. Got to watch that one. Right, so just got the squelch to do. Turn the volume down so as not to annoy people. So, that's one of the capacitors on the floor. When I die, they'll sweep up all this rubbish. So all those capacitors got changed in that one, all of them. See, these ones near the heatsink are going to get hot. It's like that one near the ballast resistor and the output transistor. It's working on this, but you know, I could change it for a laugh, couldn't I? But I don't want to add another 20 odd pence onto the customer's bill. So I really want things which are in a hot area to be changed. And these audio ones are always going to be given a bit of a hammering. So it's a really nice radio. Let's see where we are on frequency now. So it's slightly low, isn't it? But it's well within. Oh, it's 79123, folks. So as things have warmed up, that's where it is. So it's so. In 40 years' time, it'll probably need the crystal changing, and that's how I see this. This will be going another 40 years. I won't be here to see it, but a lot of these Cybernet sets are going to be 100 years old and still working. And I cast my mind back to my grandfather giving me a Philips radio, which was made in 1937, though they bought it in 1939 at the outbreak of World War II. And he gave me this radio in about I'd be 14, so we're looking at 1976. And I did sort it out. I got the service sheet for it and sorted it out, with a bit of help from a radio ham chap who worked at my dad's place. But it was so old-fashioned. Obviously it had valves in it, yeah, but it was so old-fashioned. And when you think that it was what, call it 1940, 50, 60, 70, 75, 77 years, well, I can't even spell, I can't even count, can I? 1940 to 1970 is 35 years old, something like that. So that old radio was newer than these CB radios are to me today. And although they're not surface mount, I mean, they're still packed with microchips, aren't they? So there you go. So I'm going to go over this with isopropyl alcohol. We're going to do the squelch. I'll do that right now, because it will have changed from where it was before. I've got to note what I've done here so I can charge him. So it's 1000, and if I'm going to get another clipboard. 47, 2 times 100, 220, 3.3, 2 times 47. I think that's what we've changed. CFU 455HT. I'm going to charge him 250 for that. I think they're 595 at the moment, but I'm still on stock I bought some time ago. Unlike the people who put rare and put the price up. There was a UK ruling actually about retailing, and you can't change the price of things once they're priced. I think that's probably been and gone. It was in hyperinflation days of the early 70s. Right. Squelch. Making sure the RF gains to full. Let's just make sure that the set is still doing the same synad that it was when we never did. No, we never went through it because we couldn't get 20. So I realised there was still a problem. So we'll go through it again. So I'll switch to the cyanide meter. See, you might think, oh, he's doing another Amstrad 901, but, you know, they've got different faults, haven't they? And some of them are fake ones. And it's always nice to see how badly the fake ones perform. Oh, they're crap, Amstrads are. Well, they will if if you get the fake one. I'm sure those people are like handbags. If you buy a Gucci handbag that's made by Conga Wonga Bonga in a sweatshop in China for 10p, that's probably not very good either. Right, cyanide meter. Let's see where we are. Right, scale. So I think we'll all agree that's 12. It's 0.3. I could say 0.299, but I'm going to say it's 0.3. So you see that's come down by getting rid of that distortion. Ten. Somewhere around about there, 0.24. And 20, which it will now achieve at just 0.56. That is magnificent. Right, squelch, turn it to full, and let's put the second cameras onto the attenuator. So I want it to squelch out right up to 100 microvolts. So when I hit 100 microvolts, which is S9, then it should open. 3, 10, 30, 100. Well, it doesn't. Where was it before? Well, it never opened, did it? So we need to improve that so it does open. The squelch can be funny on these sets, especially with the fake ones where it's crap. So make sure I'm really on the threshold there. It uses the built-in mute in the FM receiver chip LA1230 from Sanyo, and this LA1230 was designed for stereo tuners. It wasn't designed for communications, and so that squelch is what they call muting on in the hi-fi world. When you're tuning between stations, so you don't get the FM hiss, it goes into muting, which we call squelch, don't we? So there we go, that's set right. Now let's see where we are. It was absolutely fine at the lower end. Let's just see where that is. So we'll reset the squelch on the radio, put the signal generator to standby. That's threshold. We switch the signal generator back on. It's parked at 0.3 of a microvolt. And it's straight in. And in fact, the squelch activates at 0.3. So that's where it is. So that's exactly the same. And that is now 100 microvolts, just as it should be. That's now set correctly. Right, I still haven't charged the battery on this radio. Testing 1 2, testing 1 2. That sounds fine. Now we'll just see whether his Action Man mic. I'll get this so it works, but it will never be reliable. Testing 1 2, testing 1 2. Right, there's nothing I need to do. It works. Testing 1 2, testing 1 2. That's as far as we go. It works. No intervention. Don't know how many paper wedges are in there to make it do that. But as I said, always use these with a replacement mic. Absolutely fantastic having those original withdrawn mics, especially if you were supposed to hand them in and get a replacement. Absolutely great. But it's not there to use. It's there to be a shelf queen. So what I'm now going to do, I'm going to go over this with isopropyl alcohol. So switch the radio off, and if we've got the brush, if we've got some isopropyl alcohol in here, sometimes we have, sometimes we haven't. No, we haven't today. I'll get that cleaned off, and we'll next thing put the camera back on. I'll have put it together. No, I think I'll show you the board cleaned up. And there we are with the isopropyl alcohol all nicely cleaned. It's not without its cost, you know. It's about 50 pence every time you cleaner board like that. Right, I'll get the cases on and then we'll do that in half an hour when that's dried properly. Right, it's time to turn it on. I suppose we want to plug a mic in. There's quite a few faults, and you know, I think those capacitors have been changed relatively recently, and to change them for second-hand ones, they've just transferred the fault from one DUF capacitor to another DUF capacitor. Right, hopefully we're on the aerial. 19 Roger. There's no point even talking back to somebody on that. They're going to be on illegally high power. Just listen to Roger bleep on my walkie-talkie with a flat battery. Yep. That works. We'll do a scratchy corner test either later today or tomorrow, then that can go back to the customer. So, yeah, quite a few faults, but we've done the capacitors as a blanket job because they do all test out within what you'd expect. But the point is, there was distortion, and there isn't now. The filter, a bit of distortion, we could have sent it back. The customer may not have noticed, but I know it'll never do 20 dB cyanide, and the radio should be able to do 20 dB cyanide, so we know there's a fault. That's why we go deeply into these things. Done the ballast resistor and brought it up from 2.9 watts, as if it's a new radio, to a full 4 watt. And remember, this is an industrial test set, so if you test my 4 watts on a hobby meter, it should be something like 7.9. But this is what the government would go on a commercial meter, not on a hobby meter. So there we go. I know we've got another Amstrad in the post. I know I've got an Amstrad here, and I've got some walkie-talkies I bought. I've got a Duet walkie-talkie, 40 channel one, which is a DNT rebadged for Great Universal Catalogues at the time. I've got a very unusual Donita hand portable I've not seen the likes of before. These have all come from Night Clearance Corner, so they're going to have extensive faults on them. Be nice if I can fix something like that. In the batch was also a Realistic TRC 1002, which is the 2-channel handheld, which is 1.5 watts output, 6-mile range on those things. They are 2-channel, but they only ever came with the 1-channel fitted, which is channel 20, and then you were supposed to buy crystals from Tandy's for the other spare channel. So your second channel could be 9, 14, 19 or 30. They were the crystal options from Tandy's at the time. And so of course most of those never had the second channel fitted, so you'll find you could buy 100 of those sets and you'll find they are single channel fitted. So that's a point. So that's 3 of the sets. Then there was also an illegal radio which we'll be legally required to chop up. But it's got a telescopic error on which we can use on something legal. So there we have it, the Amstrad original Cybernet 002F version 901. And remember, the only thing Amstrad about this is that name. This is a Cybernet radio. It could say Cybernet on it, but it doesn't. It says Amstrad. So, it's crap, it's Amstrad. No, and Amstrad had some really good products. The VCR 7000 video recorder, which was their top loader, their first video recorder, with a ground-breaking price of $499.99 at the time, with an Orion Hinari VXL2. Absolutely splendid video recorder. So, and then they did some not so good ones, which were sourced from Funai. So, same applies with television sets. The Orion sourced ones always seem to be pretty good. I've not got that experience of some. the Amstrad CB901 from 1981. Thank you for watching.